Hi friends, welcome back again. In this video we are going to discuss about the metric space. In the earlier videos we have discussed about the basics of set theory, then Cartesian product, relations and different types of relations, functions and different types of functions. So I would suggest to watch that videos, then the concepts in these videos will be much clearer. Let us start. What is the metric space? The name itself suggests that there is a metric, there is a measurement. What is the measurement? What is the distance between 3 and 5? For example, we have a simple real line. Here it is 5, here it is 3. What is the distance between 3 and 5? The typical way of finding distance between 3 and 5 is basically 5 minus 3. So it is basically 2. But mathematically it is not correct. We have to take mode of this. So even you deduct 3 minus 5, that's also correct. So the distance is basically symmetry. The distance between 3 and 5 is equal to distance between 5 and 3. It is symmetrical. And it will be non-negative number. It can't be negative. If you take distance between 3 and 3, then it will be 0, but it can't be negative. And there is also a third property for a distance. Basically, it can be easily understood in a two-dimensional plane. If you take 3 points, the sum of the length of any 2 points. For example, we are taking the length here and length here. We are adding up, we will get a sum. It will be greater than the length of the third side. Anyway, you take any two sides, find the length, take the sum, it will be greater than the length of the third side. That is the triangle inequality. So if a function satisfies all these three properties, that function is called basically distance function. Let us see the mathematical definition of distance function. For finding a distance, there should be 2 points. In one dimension, that 2 points might be 2 numbers itself. But in 2 dimension, that points itself will be a vector. This will be a vector of 2 elements. This will be also a vector of 2 elements. In 3 dimension, it will be a vector of 3 elements. So we will have 2 points. That 2 points basically will give a r plus. R plus is non-negative real numbers. It can be 0 but cannot be negative. That's why we are denoting r plus is basically non-negative. If we are denoting r plus plus, then only it will be positive numbers. If this is a function, if this function satisfies these following three properties, then that function is called a distance function or a metric function. So the first property is that distance between xy is equal to 0 if and only if x is equal to y. So we have a 3 point here. So we are finding the distance between x and x itself. Then only it can be 0. Otherwise it will be greater than 0. It can't be negative anyway. Second property is symmetry. Distance between 3 and 5 is equal to distance between 5 and 3. And the third property is basically triangle inequality. So we have a distance function now. If that distance function put together with a set x, then that pair xd, this is a set, this is a distance function that satisfies these three properties, then this pair is called metric space. And the elements of x is called points in metric space. So far we have understood what is metric space. It is nothing a set together with a metric function. That metric function can be any type of distance function. It can be mode of two numbers, it can be Euclidean distance, it can be any other distance as well. Now let us take some examples. This is a simple example in one dimension. There is a line. So this R is basically a real number, that is a set. The D is a distance function that is defined as mode of that 2 points. So we have 2 points 3 and 5. We will take the difference of these two numbers and take the mode of that number. So we will get 2. This is a simple example of a metric space because there is a set R together with a distance function or metric function. That's why it is called metric space. Now let us take another example in 2 dimension. For example, we have like this. This is a 2 dimension R2 and the distance function is basically Euclidean distance. If we have 2 points here, the distance between these 2 points will be distance of this square plus distance of this square. Sum it up and take the root, then we will get distance of this. So that is a Euclidean distance function. So R2 along with Euclidean distance function is another metric space. Now let us talk about a trivial metric space. If you take any x, you can define this metric function on that and you can make it a metric space. Metric function is basically called discrete metric because the value of that function is not spread out. It is not continuous. There is only limited values for this distance function or a metric function. That's why it is called discrete. If we are putting a discrete metric function along with a set, it is called discrete metric space. Let us see what it is. X is a non-empty set. The distance function has been given like this. If x is not equal to y, it is 1. If x is equal to y, then the value of function is 0. There are only 2 values for this metric function. That's why it is called discrete metric. Putting this discrete metric function together with a set x, any non-empty set, we can make that non-empty set x as a discrete metric space. The only condition is that this distance function has to satisfy all that 3 properties. Let us look on that. The first condition says that if x is equal to y, then distance will be 0. That is given in the definition itself. If x is equal to y, then distance is 0. The second condition says that distance between xy is equal to distance between yx. Let us see whether this distance function satisfies this second condition. For example, if x is not equal to y, then distance xy is equal to 1. If x is not equal to y, then y is also not equal to x. It means dyx is 1. So dxy is equal to 1. dyx is also equal to 1. So there is a symmetry. Now in the second case, if x is equal to y, then dxy is equal to 0. If x is equal to y, it implies that y is also equal to x. If y is equal to x, then dyx is 0. So dyx is 0, dxy is also equal to 0. There is a symmetry. The third condition says that this is a distance between 2 points. It means a length of one side. The length of other side we will sum up. That will be greater than or equal to the length of the third side. Basically we can understand this in 2 dimension very easily by taking a triangle. Distance of this side or distance of any side will be less than or equal to distance of these 2 sides together. That is little bit complicated, so we will explain it in detail because there are many possible options. X is equal to y and y is equal to z x is equal to y but y is not equal to z, x is not equal to y is equal to z. There are different options. We will go through that. So for example, we have 3 points x, y, z. In the first case, all three are equal. If all three are equal, then distance between any 2 points will be 0. So 0 is less than or equal to 0 plus 0. Then the triangle inequality has been satisfied. In the second condition, x is equal to y. So the distance of xy will be 0. But x is not equal to z, y is not equal to z. So their distance will be 1. So 0 is less than or equal to 1 plus 1. Again the triangle inequality has been satisfied. In the third case, x is not equal to y is equal to z. If x is not equal to y, then distance will be 1. And x is not equal to z as well. So their distance also will be 1. But y is equal to z, so their distance will be 0. So basically 1 is less than or equal to 1 plus 0. Again triangle inequality condition has been satisfied. In the fourth case, x is equal to z, so the distance will be 0. But x is not equal to y, distance will be 1. And z is also not equal to y, distance will be 1. So again triangle inequality says 1 is less than or equal to 1. Triangle inequality has been satisfied. In the fifth and final case, none of them is equal to another point. So the distance will be 1 for all. So 1 is less than or equal to 2. Again the triangle inequality condition has been satisfied. So we have proven that this is a metric function because it satisfies three conditions: symmetric, triangle inequality, and the first condition that distance between 2 points is 0 if and only if that 2 points are same. More than this, there are different kinds of distance function that can be defined upon many set. We haven't discussed that in detail. This is only a basic introduction. You can refer different books in topology and real analysis. It will be very easy for you if you understand this basic concept. Now in the coming videos we will discuss about the open set in a metric space and closed set in a metric space. So watch the videos and subscribe the channel. Thank you.